Now this is series circuit. Three resistors of different resistances are connected like this, and current has only one path. So current for all of them will be same. And this is the rule number one for a series circuit. Current is same for all of the resistors. In a pure series circuit, all resistors get same current. Yeah. Now, rule number two is potential difference is split among resistors according to their resistances. As V equals to IR, if I is same, which is same in this case, in series case, so V is directly proportional to R. The one that has more resistance will have more potential difference. The one that has less resistance will have less potential difference. That's why if you want to know, listen, some of the things we can do on the board or on the circuit. What is the potential difference for resistor number one? It is I into R1. What is potential difference for the resistor number two? It is IR2. What is potential difference for resistor number three? It is IR3. It is also V1, V2, V3. Okay. So V1 equals to IR1, V2 equals to IR2, and V3 equals to IR3. This is one way of finding them. One other way, depending on this directly proportional relationship, is that if you need V1, which is potential difference across the first resistor, you can do it this way. Resistance of the resistor you want to find the potential difference across divided by sum of resistances that are connected in series, including the one that you're finding resistance across. So total resistance in series multiply by V. V is the potential difference that is to be split between the resistors. So this is one way of finding out what will be the potential difference without finding current. For this method, if you understand this method, you don't need to find current. What you can do is resistance of this divided by the total resistance multiplied by V. If you want to know the potential difference for the R2, which is V2, you can do R2 divided by R1 plus R2 plus R3 multiplied by V. So this is how you can find different potential differences without even calculating or finding current. So now in series, if one resistor fails to transfer current or conduct current, the whole circuit fails. If one resistor fails to transfer current, then whole circuit fails. Now, one switch will control all separate switches cannot work. So that is also a property for series circuit. Now, as we know, V, which is the potential difference for the battery, equals to V1 plus V2 plus V3, and V equals to IR, where R is total effective resistance. V1 is IR1, V2 is IR2, and V3 is IR3. So we know that V equals to V1 plus V2 plus V3, and V equals to IR, where R is the total effective resistance, and V1 and V2 and V3 are, they can be written in terms of I and R1 and R2 and R3 like that. If I put the values of these V1, V2, V3, and V into the first equation, I should get something like this. I R equals to I R1 plus I R2 plus I R3. So can I take I common on right hand side? Yes, I can. And that I will be cancelled with I on the left hand side. And we will be having R1 plus R2 plus R3. So to find total resistance for resistors that are connected in series, we just have to add those resistances together. That will give us the total resistance. Now, special cases. For n different resistors, we can use R equals to R1 plus R2 plus R3, and this series can go up to Rn. For n identical resistors with individual resistance R, total effective resistance is n times R. So if you have n resistors and they are all same, they all have same resistance of R ohms, to find their total resistance, we just simply multiply the number of resistors with the resistance of each resistance. Okay, so these are some special cases for series circuit.
Sir,
Yes,
could you explain that switches part again? That one switch will control all and separate switches can't work.
like for example, is it possible that you turn on R1 but to turn off R2 and R3?
No.
So that is what I meant, that only one switch. You can put one switch anywhere. Like how many places you have for putting switch? One. You can put switch over here two, switch over here three, switch over there four. But when you open it, all circuit will close. All of the resistors will off. And if you close it, all of the resistor will start working. It is not possible to provide separate switches like in your home. You want to turn on anything you want to, and sorry, you can turn on anything you want to, and you can turn off anything you want to, and rest of the things they keep working properly. One thing for sure, things at your home are not connected in series with one another.
Yes, I
Okay,
got it. Thank you.
so in series you cannot provide separate switches for things that are connected in series. Some electric components are always connected in series. For example, some electric components are always connected in series. For example, ammeter, fuse, switch, circuit breaker, etc. So if you want to find out how much current is passing through a certain component, you are supposed to put ammeter in series with that component. You want to put a switch to control a circuit or component in a circuit. You are supposed to put the switch in series with the component that you want to control with that switch. So switch, fuse, circuit breaker, they're always connected in series uh, for their purpose. Okay. So anything we left for series circuit, let's leave some space over here. If something comes to our mind, we can put it over here. Now, parallel circuits. What if resistors are connected in parallel? Now, this is a parallel circuit because current, when comes to this point here, it is a junction. Here is a junction. So current, which is coming over here, let's say current is I, and resistors are resistor number one, resistor number two, and resistor number three. And they are, for example, different, all of them. So current will be different for all of them. There will be current I1 for this one, I2 for this one, I3 for this one. So current, when reach this point, this one, it will split into three different parts. And at this point, current will merge back into the same value, and the same current that will leave the battery will come back to the battery. So current here will again become the same I as it was over here. So this is parallel circuit. Now, what are the properties? Number one, all resistors get same potential difference. Like, for example, AC that is at your home works at 220 volt. The energy saver at your home works at 220 volt. Your fridge, your computer, your mobile charger, the side that is plugged into the socket works at 220 volt. Excuse me. Now, what is the total voltage that is coming to your home? If you go to the main switch or the main supply, that is the the point where the electricity is coming to your home, you will find out it is also 220 volt. How is that possible? What kind of circuitry at your home is? Like, is it series or parallel? Because if you turn off your fan, the rest of the things they keep working properly. If you turn off your fridge, rest of things are okay. If you turn on fridge, nothing happens to the rest of the things. What kind of circuitry is that? Series or parallel? It should be parallel because everything is connected in a way that it is getting the same potential difference. And you can get the same potential difference only if things are connected in parallel. For example, this battery is of 12 volt. If this is 12 volt, how much R1 is getting? Answer is 12 volt. How much is R2 getting? 12 volt. How much R3 is getting? 12 volt. And what is the total? 12 volt. So volt is actually energy per unit charge. We see charges split. Like 10 of them go over there, 3 of them go over there, 5 of them go over there. Obviously, number of charges are different. But how much these 5 are having individually? How much energy every single one of these 5 have? It would be same as the energy every single charge had when it was coming out of this battery. So only 3 went on this one. Every single one will still have the same energy. Every single one will have same energy because volt is energy of a unit charge. Some of the units are going there, some of the units are going there, some of the units are going there, but the energy for a unit is still same. So all of the resistors get same potential difference. The circuitry at your home is parallel. And remember, we can provide separate switches. If we provide separate switches over here, we turn off R number one, R2 and R3. They will not even notice that R1 is gone because there we are ignoring internal resistance and there will be no effect to R2 and R3. So all resistors get same potential difference in parallel circuit. Current splits among resistors. Largest resistor gets least current. And that is because Ohm's law, V equals to IR. If V is same, which is same, I and R are inversely proportional to each other. So The biggest resistor will have least current, and that also makes sense. If current comes over here, where there will be more resistance, less current will go over there. Where there will be less resistance, more current will go over there, like the traffic does. Okay. Now, mm, separate switches can be installed if one is turned off. The rest of resistors work normally. Okay. For example, any energy saver at your home uh, stops working. It it is damaged or something. It is broken, for example. It is not like the whole house will like like having electricity failure. Rest of the circuit will keep working because everything is connected in parallel. If one stops working, rest of the things they keep working properly without any issue. Now, some mathematical things that we need to understand about this one. As we know, the same current that goes out of the battery splits into three branches: I1, I2, and I3. Because of the law of conservation of charge, charge cannot be created nor destroyed, and it never decreases or increases. Uh, Total current is the sum of I1, I2, and I3. Now, we know I equals to total V over total R, where R is effective resistance. I1 will be V over R1. This will be I1, and I2 will be V over R2. I3 will be V over R3. So I can replace these values into the first one. All these values go in this one. It becomes V over R, where R is the effective resistance, V over R1 plus V over R2 plus V over R3. From the right hand side, I can take V common. It will become 1 over R1, 1 over R2 plus 1 over R3 equals to V over R. So we can simply cancel V and V, and you will have the formula for total effective resistance in parallel, which is 1 over R equals to 1 over R1 plus 1 over R2 plus 1 over R3. Just uh, now, special cases. Now, number one, if n identical resistors of resistance are are connected in parallel, then the total resistance will be resistance of the individual resistor divided by n. And that is a very important formula. If we connect n resistors, each of resistance R, and they are identical, that means they all have same resistance, then their total resistance is resistance of one divided by n. Now, for two resistors in parallel, total effective resistance is product over sum. That means R equals to R1 multiplied by R2 over R1 plus R2. But remember, this is only for how many? Two resistors. If resistors are more than two or less than two, you cannot use this thing. So this is a special case for two resistors. We can say, like some of the students find this thing a little difficult because first you have to add the fractions and then at the end you have to flip the fractions to find the value of R. But this case, for this way, you can do it directly, but you cannot do it for three resistors. If you think that R1 into R2 and R3 over R1 plus R2 plus R3 will work the same way, then you are wrong. It won't. It will only work for two resistors. You can just multiply the resistors and add the resistance and divide these two numbers, and you will get directly what you will get by using this method for two resistors. So, any queries till now? Any questions? Anything that does not make sense? No?
No, sir.
Good. So, last thing of the day, and then we can do something else, is a question. Okay. Question. This represents a resistance of 6 ohms. How many ohms? 6 ohms. So, all of the resistors are 6 ohm of resistance. Like, you should not be confused as whether it is 5 ohm or 4 ohm or 10 ohm or 8 ohm. Like every rectangle you make, it will be 6 ohm. You have four of them, and you use all at a time to make a circuit that has a resistance of
So,
Yes.
मेरी तबीयत सही नहीं है तो क्या मैं क्लास लीव कर सकती हूँ?
Sorry.
मेरी तबीयत सही नहीं है, क्या मैं क्लास लीव कर सकती
Yes, you can. I will be sending this question, and when you feel better, you are supposed to solve this question. Okay.
हूँ? Okay, sir, thank you.
So for every question, you have to use all four of them. You have to use 4 resistors for every single part. Make a resistance of 24 ohm. 1.5 ohm, 15 ohm, 8 ohm, 4.5 ohm. What else you can make? 6 ohm. And you have to connect 4 of the resistors, 4 6 ohm resistors to make a total resistance of 6 ohm. And you have to do it in 2 different ways. Okay, take a screenshot of this thing. This is your homework. See you people tomorrow. Allah Hafiz.
Sir,
Yes.
the sixth and seventh one are the same.
Yes, because you have to do it in 2 different ways.
Okay.